Number 10. An equilateral triangle is graphed below. Which of the following reflections would map the triangle onto itself? Well, letter A, a reflection across the y-axis. That means that we're going to take this triangle and we're going to have to go across the y-axis, which is here. So our triangle would land somewhere over here. And we want it to map back onto itself. So that's a terrible picture, but that's not going to happen. Not A. If we reflect across the x-axis is here. So our triangle, if we reflected it, try to draw a little bit better of a picture, would look like that. And again, what the question is asking is which of them would map the triangle onto itself. So that's also not going to map back onto itself. And we can cross off B and we can cross off A. So a reflection across the line y equals 5. Well, y equals 5 is this. And again, clearly the top part of the triangle is not going to land onto the bottom of the triangle. And we want this to map back onto itself. So let's see if D really does work. And D says a reflection along the line x equals 5. Well, x equals 5 is here. And if we folded that triangle, then the right side of the triangle would definitely land exactly on the left side of the triangle. So D is a solution to this problem. Number 11A. Draw all lines of symmetry for each figure below. Count and write the total number of lines. Then determine if each figure has rotational symmetry. If yes, find the order and the angle of rotation. Well, lines of symmetry. There's a line that goes right down the middle. Vertically, there's a line that goes right down the middle horizontally. So there's two lines of symmetry. Well, we're looking at the order, and I'm not sure if I can do this, but I'm going to try. I guess I'm going to change colors. I'm going to try to trace this figure. Oh gosh. I'm going to try one more time. And apparently to the left, the board's slightly disoriented, but let's see if we can still see this picture here. And what we're looking for is we're looking for the order. This it doesn't tell us anything about whether it's regular or not. But if we turn this, we don't land here, but if we keep turning, do we land on itself? And we do. And then when we go around again, what happens here is that the order of this picture is 2, because it takes us, we can go one time around, we can go from here, essentially actually we went from here to here, and we landed on itself, and then we went from here to here, and we landed on itself. And what happens then is our angle of rotation is determined by taking 360 and dividing by 2, and our angle of rotation is 180.